सो लास्ट क्लास हर्षित आपने रिवीजन किया लास्ट क्लास में जो हमने किया था डिस्पर्शन ऑफ लाइट एंड ग्लास प्रिज्म।
वैसे तो थोड़ा टाइम मिल पाया करने का वैसे।
हम्म।
सर लाइक ये थोड़ी गेम है।
अभी नहीं किया।
सर थोड़ी की एक्चुअली वो
और
होमवर्क भी थे
किया।
ना मुझे स्कूल के टाइम नहीं मिल पाया।
व्हाट अबाउट यू आयशा?
Sir, what are you explaining?
No, I'm not explaining anything. I'm asking that have you done the revision before coming to the class?
Yes, sir.
Assalamu alaikum. Hello Aisha Sultana. How are you dear?
Walaikum assalam. Alhamdulillah, fine, sir. How are you, sir?
I'm good, dear. Good. Stay. I'm audible. Aisha, I think so. Your batch is P1, right?
Sir, I actually asked them to take my class early because I have to go somewhere.
Okay, okay. ठीक है आयशा। Assalamu alaikum dear. How are you? Audible?
Walaikum assalam, sir.
Arshit, Aisha, Maha, please switch on your camera here. Aisha, do you have any issue in the camera because your screen is black, like right, everything is black.
No, sir, I can see myself.
No, actually your screen, I'm not able to see your video because your screen is blacked out. That's what I'm saying. Smaya, please switch on your camera. Aisha, Sultana, please switch on your camera, dear. Because we have to start the class, right?
Sir, now can you see?
Maha, no, I cannot. Maha, same goes with you. There's a cross camera signature on your screen, Maha. Please check. I think we have not given permission to the camera, maybe. Yes. No, Maha, I cannot see your video, dear. Okay, so in the last class we have started the dispersion of light. Please check your videos, Bichur. Okay. So till I'm starting, please check your videos before that. Okay. So I'm saying that we've started the dispersion of light in the last class. Okay. So dispersion of light means the splitting of white light into its constituent colors. So what are those constituent colors? Those are 7 colors. And thus you can say, if I say in short form, that is called Vipcure. And the band of those 7 colors is called spectrum of white light. Okay, Maha, ठीक है, no worries. Okay, no worries. Please check the issue before the next class. Okay. No need to worry. So, okay, so I was saying that band of light, those the band of 7 colors of the white light is called spectrum of white light. Okay. So that's what is spectrum. So what happens? Suppose that right now, here you can see this thing that if I place a prism, so white light split into its 7 constituent colors. What happens if I place another prism in the opposite direction? What will happen? What will happen if I place the prism in the opposite direction after this splitting of light? What would happen to this band of colors? What would you say? Any idea?
So they will mix each other.
Okay, Harshit said. What about you, Maha, Aisha, and Aisha?
They will turn into white light.
Okay, turn into white light by Maha. Any answer from Aisha and Aisha Sultana?
So I did not understand the question. Can you please tell me?
Okay, sure. So I'm explaining. So basically, this will happen. So if suppose that I've placed a prism, glass prism in front of a white light, so white light will split into its constituent color. So this is a band of 7 colors. But if I place a prism invertedly, okay, if I place an inverted prism in front of this band of colors, so what will happen is that this prism will act, or you can say will combine all the colors, and the emergent light would be a white light ray. Clear? In this case, this is called recombination. Clear?
Yes.
Okay. Sure. Okay. So, and you can see this thing here. This is a white screen. So, on this, you will see a kind of white patch of the white light. Yeah. So this happens. So suppose that there could be a question that what will happen if you basically if the band of 7 colors passes through an inverted prism. So what options could be that it turns into white light, it will remain as it is. So these are the options that would be there. Okay. So whenever the white light splits into its constant color, to basically recombine them, you have to place an inverted prism in front of the band of 7 colors. Okay. Clear? Aisha, Maha, Aisha, Nuha, Harshit, Sumaya, are you there?
Yes, ma'am.
Yeah.
Okay. Okay. Sure, let's go. Hi Nuha, assalamu alaikum. How are you, dear?
I'm good.
Nuha? Oh, sure. Nuha, please switch on your video, dear.
Yes, one second.
Okay. So this happens in this dispersion of light. Now let's talk about the most important thing in the real world that we see the dispersion in the real world. That is the rainbow. You must have seen that after the sun, after the rain. So what will happen in the basic? This basically appears in mountainous region, or you can say coastal regions, right? So you must have seen that the rainbow forms after the raining. Yes or no? Okay. So rainbow. Let me write it here. This is the application of dispersion of light. The rainbow after raining. So if we talk about what do you mean by rainbow, rainbow is nothing but rainbow is an arc of 7 colors which is visible in the sky after the dispersion of light by the droplets, raindrops. Okay. So let me write it here. The rainbow is an arc 7 colors visible in the sky which is produced by the dispersion of sunlight by raindrops in the atmosphere. Okay, so basically rainbow is formed of basically in the sky by the dispersion of the sunlight by the rain droplets. Okay, so it happens because when the rain after the basically when the rain happens, the water you can say water droplets suspend in the air, you can say atmosphere, and those water droplets act as a you can say glass prism like thing, and it basically disperses the light into its constituent color, and that's how the rainbow is formed. Okay, so let me you can say show you the let me show the actual scenario. How does it happen? Is this visible to everyone?
Yes.
So you can see this thing that this is a sunlight. So basically this water droplet is suspended into the atmosphere. So what will happen is that this white light will strike the water surface. And as you can see this thing outside is air, and in this is a you can say water droplet. So medium is changing here, so diffraction will happen. So you can see this thing that each ray is basically refracting according to its speed. Okay, so here this is the here this at this point refraction is happening, and inside this when the refraction happens, so it splits out due to the change in medium. Okay, so this is the dispersion point. As you can see, so now this light is basically, okay, TIR is the total internal reflection. So it happens when the light completely reflects inside its surface. So there are some certain conditions that is not the part of your syllabus. What are the conditions of TIR? So TIR is nothing but it's the reflection. It means that if suppose that light is changing its medium and the light again reflects into the same medium, that is called TIR. Okay. So after TIR, so you can see this thing light is basically coming outside the water droplet as a band of 7. This is our eye. That's how the rainbow is formed. Clear, everyone? Please let me know.
Yes, sir.
Yes.
Any doubt to anybody? Anyone?
No.
Are you sure, everyone? Sure. Okay. So that is the rainbow. Okay. So basically, in the atmosphere, these water droplets act as a small prism. Okay. The rainbow. The raindrops, sorry. Atmosphere. Like management. Please let me know, everyone. Is this clear to you or not?
Yes, sir.
So there you go. So this is not necessary that rainbow will always form on a rainy day. Sometimes you can see this thing when there are certain mountainous region and there are fountains. So basically that fountains spreads the water droplets into the atmosphere. And you have also seen that near the falls, you can say waterfalls, the rainbow is also formed without any you can say rainy day. On a sunny day, you can observe the rainbow near a you can say waterfall of any area. Like Niagara Fall is
Is
one
it
of
due
the.
to the evaporation process?
No evaporation. Basically, what happens is that when the water droplets are very small particles in the air that is suspended. Like there are multiple types of sizes in the water droplets. So, though the heavy water droplets basically will drip into the water itself, and the very small particles will suspend into the air. You must have seen the mist. Have you heard the mist? That spray mist?
Yes.
Yeah, those will be the you can say size of those particles that is suspended in the air. Okay. Clear, everyone? Is this clear? This rainbow part?
Yes, sir.
Yes, sir.
Anyone? So basically what happened is that the water droplets act as the small prism and how the, you can say, so I'm writing it here, it's last point. A rainbow is produced. Hmm, dispersion. By raindrops. In the atmosphere. Yeah. Each raindrop will, raindrop acts as a tiny glass prism, splitting letting the sunlight into spectrum.
Sir,
Yes, Maha.
what's written after each raindrops acts as a
So basically, they go only a single rain. If you want to see a raindrop, if you want to see a rain, so
No,
you
no, sir.
can
I'm
see
asking what's the word?
each tiny glass prism splitting the sunlight into spectrum.
Okay, thank you,
Tiny,
sir.
tiny. Then everyone, everyone, please tell me.
When, sir?
Sir, the sun
Ah,
is yellow or like orange. So why does it appear white?
okay, so sun does not appear, so basically sun appears yellow or orange in different uh, time of the day. Must have seen that in the morning time, sun appears to be orange or reddish type. This is due to the you can say scattering of light, which we will study in the later part of this chapter. That is the scattering of light. Okay, so and when the sunlight is basically you can say is in the afternoon, it's basically above the head. So when the light travels through the atmosphere, it does not refract at all. So basically, all the light that travels from the sun is in the form of white light. Okay, so that's why there are certain
Okay.
angles which need to be considered before saying that whether its sun is a red, orange, or yellow. Okay,
Okay, sir.
so yeah, let me just a moment. Let me resize it a little bit, and I just wanted to write 2 lines about this. The white seven colored light, this spectrum. That was seven. Seven. Light is and will combine to give a white. Is this clear to all? If you please let me know.
Yes, sir.
Yes, sir.
Sure, everyone. Just a minute. Okay, so I just wanted to ask, is the atmospheric refraction, because I've seen the syllabus right now. So twinkling of stars and why planets do not twinkle, are these are the things are the part of your syllabus? Just let me know once. Like they have a teacher have basically taught you in the class, because as per the CBSE syllabus, these are like like you can say just a second. Sim dispersion static. How many how many of you have done the like human eye in your schools? Anyone who has completed this chapter in the school?
Sir, half
Half. Uh,
half of the chapter.
how much?
1 second, sir. Let me check.
Please let me.
Sir, till apparent
Was
myopia, defects of vision and the correction. We have done till there, and I'll tell you what is deleted in my syllabus.
yes, please let me know.
Why is the color of the clear sky blue? From there till the last thing. Color
The
of the
sunset
sun at
sunset.
yeah, that's also deleted. And
Atmospheric
before that,
refraction is not deleted.
no, it's not deleted.
It's but it's not mentioned properly. Why? Just a second. Let me open the NCRT.
So actually, in maths also some things are deleted if you will check the website, but teachers are teaching that and those things are coming in the test.
But what basically the paper of 10th class will not be formed by the schools. So maybe teachers are just a second. Let me check. Let me open the NCRT first. Okay, so if okay, let's do atmospheric refraction, but basically this is not like this thing is not mentioned in CBSE syllabus, but we will do because that is not a very big topic. Because suppose that sometimes there are possibilities that they basically combine one or two things into a single topic. Like maybe they have included this atmospheric refraction into the dispersion of light because atmospheric refraction is a little bit similar to the, you can say, is the real world application of the, you can say, of the refraction. Let applications of lens. Okay, so let's do the atmospheric refraction. Okay, because sometimes CBSE says that this is the included portion and this is okay. So this is the part of the dispersion. Is this clear to everyone? Please let me know.
Yes.
Yes, sir.
Okay. So after this class, assessment will be active. Please, you have to go and check out the assessment. Okay. So please do not miss the assessment. I'm basically doing it. It's done. Okay. So assessment will be active. So you have to go and check out the assessment. Okay. Let's talk about the next topic of this chapter, that is atmospheric refraction. So as you guys basically, as you can suggest from the name itself, that what basically atmospheric refraction will be. So it's nothing but it's the refraction that happens in our atmosphere, that is called atmospheric refraction. Okay. So now we have to understand why does it happen. So basically, so they go. Suppose that this is this is our atmosphere, complete atmosphere. Okay. So atmosphere varies layer to layer. There are multiple layer in the atmosphere. You must have heard toposphere, stratosphere, lithosphere,
Yes,
mesosphere. Like I'm not able to recall all the name right now because I've heard, like I've learned this thing when I was in eighth or seventh or eighth class. But these
yes,
are
it's
the
in geography.
layers, right? Lithosphere, toposphere, or mesosphere, and आपका होता है you can say stratosphere. So these are the layers. So every layer have different density. And what we have learned in the refraction part is that whenever the density of a medium changes, the light ray will refract, will bend. Okay. Obviously, it will bend because the medium is changing. The density of the medium is changing. Everyone, please let me know. Is this clear?
Yes, sir.
Okay.
Yes, sir.
So that, okay. So this is the reason for the atmospheric refraction, because atmosphere have multiple air layers and have different optical densities, which basically refracts the light ray. Okay. So let me write it down what basically atmospheric refraction is. Okay. So A part is about the atmospheric refraction, that the refraction of light caused by Earth atmosphere caused by Earth's atmosphere having air layers of varying optical densities. It's called atmospheric refraction. Okay. Okay, is this clear to all of you? Please let me know why, what is basically atmospheric refraction. So the refraction caused by the Earth atmosphere due to the varying optical densities of layers. So that is called atmospheric refraction. Clear, everyone?
Yes, sir.
Yes or no?
Yes, sir.
Okay. And the reason behind that is basically, so in the atmosphere, we have different layers having different optical densities. Okay. Yes. Different optical densities. Minus same. Okay. Everyone, is this clear to all of you?
Yes, sir.
So basically, so these, so there are multiple, you can say, phenomena that we observe due to the atmospheric refraction. First one is twinkling of stars. Second is advanced sunrise and delayed sunset. Why do we see advanced sunrise and delayed sunset? And some of the, you can say, other phenomena are like why planets do not twinkle, why the star seems higher than they actually are. Okay, so these are the reasons. So basically, in NCERT, only two are given. That is the twinkling of stars, and the next one is the advanced sunrise and delayed sunset. Okay, so let's understand that portion. Okay, so this is a very small topic, not that much tough or you can say lengthy. So the first is twinkling of stars. So you must have seen that in the sky, in the basically in the night, when you basically lay down on the floor and basically see towards the sky, what you observe is that the stars twinkle. It's just like a blip, blip, blip. Yes or no, everyone? Yes, yes, no. No one,
No,
no
sir.
one. Nobody has observed the twinkling of stars so far.
No.
Sir, I have seen, but nowadays we can't see.
Yeah. So basically, these are like twinkling of stars can be observed when in the you can say summer nights. Okay, so right now it's summer, and majority of the times you will observe these things in the villages, in the towns. Because when I went to my like when I visit my village, so I obviously like I frequently observe this thing. But in like the metropolitan cities, like we do live in, so they don't like we cannot observe these things because there are so much there's so much pollution in the sky. So that, okay, so this is the reason. But when we see in the village, when we see the sky in the village, we observe these things because the pollution is very less. So the reason is that basically this happens due to the atmospheric refraction. First, the main reason is that. The another reason is that the continuous changing of the atmosphere. They go stars. So what happens is that let me just write it down here first. Because that twinkling. The reason behind is that continuously changing atmosphere diffracts diffracts the light from the stars at different amounts from one Yeah, no. Okay. So basically, when the light travels from the star to the Earth, so basically what happens is that the atmosphere refracts the light by different. So it happen. Basically it leads to that sometimes the light will increase. So sometimes the light coming from the stars will increase and sometimes will decrease due to the different amount of refraction refracted by the atmosphere. So you will observe that the light is basically the stars are twinkling, but actually they are not twinkling. The only reason is that the atmosphere refracts the light by different amount. It is a natural phenomenon, so we do not know what is the exact amount of light that would be refracted by a certain atmospheric layer. Okay, so that's why we observe that twinkling of star is happening. Everyone, is this clear?
Yes.
Okay. The starlight reaching our eyes increases or decreases continuously. It is the recurring process. It happens spontaneously when the light travels from one layer to another layer. Okay. Continuously due to atmospheric refraction. The stars. Here to twinkle. Please let me know everyone if this clear to all of you.
Yes, sir.
Without
Yes,
so
sir.
far to anybody. Harshit, Maha, Aisha, Isha, Nuha, and Sumaya.
Yes.
Nuha, here, Richo. Okay. So it happens because the different layers refracts the light by different amount. So this is not certain which layer will refract how much light. Okay. So that's why this light continuously increase and decrease. That's why they appear to twinkle. Clear?
Yes.
Sure. Okay. So just a second. So one more conceptual questions arises: why planets do not twinkle? Anyone? Like as we can see, like stars are twinkling, why planets do not twinkle? Anyone?
So because in some planets the gas are filled, like in Jupiter.
Anyone? Maha, Aisha, Aisha, Nuha, Sumaya. So what happens that? So basically, the planets do not twinkle because planets are much closer to Earth. They could, because stars are basically, you can say, are very far from the Earth, right? They're like the star looks like very point-sized objects, but they do not are point-sized object. They are even bigger than the sun. The stars are bigger than the sun. Okay, when you read this thing, you will observe that stars are much bigger than the sun, but they still appears to be very point-sized because they are very far from us. Okay. Okay, but if we talk about the, you can say planets, so planets are much more closer than the Earth. So it means that they can be seen easily. Okay, so this, and when the light comes from the planet, so that does not cause that much refraction in by the atmosphere. So that's why this appears to be a stationary object. Okay, so that's why planets do not twinkle because they are very much closer to Earth. And the second reason is that the light coming from that planet is not that much, we can say, refracted by the atmosphere. Okay. So the question is that once we said this is the planets, when is the just side. Instead, reflect density light density light. Basically, first reason is that they are not a source of light. So instead of basically producing, basically emitting their own light, they reflect the low intensity light reaching to them, okay, by the sun. Second reason is that they are much closer to Earth. Okay. Closer to Earth than the distant stars. Check. Means the shift due to is clear, everyone.
Yes.
The last point is that the size of the planets are much bigger in comparison to the stars. So, hence, the shift is not shift means light shift. It's not enough to twinkle. This will be the questions. This question will appears like that: why planets do not twinkle instead of stars? So these will be the reason, because planets are not source of light. They reflect the light coming to them. They are much closer to the Earth, so that's why the shift due to atmospheric refraction is very smaller. So we cannot like observe any twinkling, and they are much larger in size. So that's why the shift is not enough to twinkle the planets. Please let me know, everyone, is this is clear to you or not?
It's clear, sir.
Any doubts so far to anybody?
No, sir.
No, sir.
So only a single part of this atmospheric refraction is left. That is the delayed sunset and advanced sunrise that we will do in the next class. And this topic will be done. So only a single topic will be left. That is scattering of light. So scattering of light is also a single topic, we can say a topic of for a single class. So in the next class, inshallah, we will be done with the chapter. Okay. So from you can say the light chapter and the human eye chapter will be done. And these are the two chapter. I hope so will be there in your midterms as well. Like once after your school will be open, these will be the
So
chapters
we
that will
don't
be there.
have
Yes, Aisha.